All right, guys, obviously I'm gone. We can't stop. We have a lot of material we have to get through the rest of the year, and believe it or not, this quarter is going to go by really fast, so we're going to keep moving. I forgot to mention in my sub notes that there are packets of notes for this class that they need to receive. They've been filling them out as we go, but I hang on to them. So they are on top of my filing cabinet in a stack. They're some white stapled packets. So if you would please pause this video and pass out those note packets to everybody who's here, and then go ahead and hit play again. All right, guys, everybody should have their note packet now. Go ahead and flip it to page 9. It starts with lesson 8.4, the slope of a line graphically. So not yesterday, a couple weeks ago, the last thing we did was we were graphing lines using the x and y intercepts. So let's go ahead and do this starter. We'll do it together since it's been a couple of weeks. It says find the x and y intercept of 2x plus 3y equals 0 by the intercept or cover-up method. Or we can make a table, then graph the line. So let's do our cover-up method. I have to set up my 2 points. I'm going to plug in my zeros. So let's plug in 0 for x. If I plug in 0 for x, then 2 times x becomes 0, so it's gone. That means that 3y has to equal 12. So what number times 3 equals 12? I divide both of them by 3, and I will find out that the answer is 4. Y would equal 4. Then I need to plug in 0 for y to find my x. So when I plug in 0 for y, 3 times y becomes 0, so I cover that one up. Now I have 2x equals 12. What number times 2 equals 12? I divide 12 by 2 and find out that that should be 6. X would have to equal 6. Now all I have to do to graph this line is to plot those 2 points. So we'll start by going over 0 and up 4. That's the first one. That's my y-intercept. It's where the graph intercepts or crosses the y-axis. My second point will be over 6 and up 0 right there. That's the x-intercept. That's where the line crosses the x-axis. To graph a line, I just now connect the 2 points using a straight line. And there we go. And we're done. It's that simple. Okay? That was what we finished with. So let's look at these two for a second. Which slope is steeper? How would you know? So if you look at these two pictures, take a second and let's all think for a second. Which one of those is steeper? Hopefully we're all thinking the one on the left. Okay? How would we know though? They have the same height, right? They're the hill. Let's imagine it's a hill. We've got skiers on there. The two hills are the same height. The first one has a shorter distance to go, right? It's dropping the same amount. They both start here and they both end here. So the heights are the same, but the distance that they're going is shorter. That's what's making it steeper. Okay, so yeah, you're right. That first one would be steeper. In math, we call steepness slope. The steepness of a line we refer to as slope. It compares how high you go or how low you go, the change in y, up or down, to how much distance it takes you to go over, the change in x. So let's just do a little bit of vocab. Go ahead and fill this in on your packet. The slope of a line is the steepness of a line. The slope of a line is the steepness of a line. The rise is the change in y. We can write that as the change in height. How far do I go up or down? The run is the change in x, or the change in distance. How far do we go? Okay, so let's go ahead and make sure we have those down. If we need to pause the video, we can. Let's make sure that everybody has that on their boxes. Okay, slope is the steepness of a line. Rise is the change in y, or the up and down. And run is the change in x, or left and right. Okay, so for this example, we're going to find the slope of each line to prove why one is steeper than the other. Okay? And it's kind of hard to do. Which line is steeper, the red one or the blue one? If we think about it, the red one is steeper, right? It's going higher in a shorter amount of time. The red one, they both start at the same spot. The red one is actually getting higher though, right? And it's doing it sooner. The blue one takes longer and doesn't get as high. So if we were just going to talk about it strictly in terms of words, that's what we would say. At the very bottom of the page, we're going to talk about the slope of a line as being 2 points. Given 2 points on a non-vertical line, it just can't be straight up and down. So given 2 points, you can find the slope using this formula. The rise divided by the run. Okay, so when calculating slope, y is always on top. This is important right here. I want you guys to star that or circle it. When calculating slope, y is always on top. So imagine we're walking upstairs. You always lift your foot before you move it over. If I was walking up a staircase like this, and my foot is right here, right? There's my knee. If I tried to go, I have to go up before I can go over to put it on the step. If I tried to go over first, I would kick the stair every single time. I'd stub my toe a whole lot and I'd probably trip. So if you think about slope as climbing stairs, you always have to go up before you go over. Rise comes before run, which is why it's on top. So if you look at this example right here, my 2 points are 5, 4, and 3, 1. The rise means how many units up did I go? We can just count. I went up 1, 2, 3 units. How far over did I go? We can just count. I went over 1, 2 units. My slope is 3 over 2. And it's that simple, guys. Figure out how far up you went and put it on top. And you figure out how far over I went and I put that on the bottom. Okay, so the slope of this line would be 3 over 2. I rise 3 and I go over 2. Or I run 2. I go up 3, over 2. That's how I find the next point on my line. Let's turn the page. So we're going to plot the following points and then use the graph to calculate the slope. So it's not too hard. There's just 2 points here, 1, 4, 3, 10. So let's go over 1, up 4. Let's go over 3 and up 10, somewhere like right there. Okay. I need to figure out what the rise is. How far up? How far up did I go, right? Rise means up. Well, I went up from 1. I went 1, 2, 3, 4, 5, 6 spots up. And how far over did I go? 1, 2, right? From 1 to 3. So I write it as a fraction with my rise on top, 6 over 2. Now we always reduce our fractions. 6 divided by 2 is 3. Please make sure we're filling this in as we go. This will help you a lot later, guys. Okay. So the slope of that line, or the m, we're going to come back to that later, is 3. Let's do the second one. 1, 8, and 2, 5. So I go over 1 and up 8. Remember, x always comes first. Y is always second. Then I go over 2 and up 5. This one's going down, isn't it? That's going to be interesting. So if we count how far up I went, I would have negatives because I didn't go up. I went down. It's the opposite. So how far down did I go? Well, I rose. I went up negative 1, 2, 3 units. Or I went down 3 units. So my rise is negative now. I went down 3. Down is always going to be negative. Up is always going to be positive. How far did I run? Well, I started at 1 and I went over to 2. So that's just 1. So my slope, or my m, is going to be the rise divided by the run. Well, negative 3 over 1 is just negative 3. Okay, I know it says slope equals m down there. We're going to talk more about that tomorrow. Just know that slope and m are the same thing. Okay, I want you guys to do this last one by yourself. So let's go ahead and pause the video for a second. Give this one a try. Mrs. Sullivan can walk around and help anybody who's stuck. Let's make sure that we give it a try. Everybody's working. Go ahead and pause it for a minute or two, whatever it takes, until everybody's tried it, and then come back, play it again, and I'll do it for you. Ready? Go. Okay, hopefully we're done. We're going to plot our points. -3, -2. I'm going to go backwards 3, left 3, and then down 2. There's my first point. Then I'm going to go left or right 0, right? I'm not going to go anywhere. I'm just going to go straight up 5. There are my 2 points. How far up did I go? We can count. 1, 2, 3, 4, 5, 6, 7 up and over. 7 up. And then I went over 1, 2, 3. I went up 7 and over 3. So my slope, or my m, is going to be my rise over my run, 7 over 3. That is the slope. We can leave it as a fraction. It's already reduced. I don't have to do anything to it. We don't have to make it a decimal. We'll just leave it like that. All right. Horizontal and vertical lines are a little bit weird. Let me show you. 0, 8 is right here, and 7, 8 is right here. So this line is horizontal, right? It goes straight across. I'll make my points bigger so we can see them. How far did I rise? How far up did I go? This thing's in the way. How far up did I go? I didn't go up. It went straight over. I rose 0, but I ran, or I went over 7. So my rise over my run, my slope, is 0 over 7. Can I divide 0 by 7? If I have $0 to give 7 people, how much does each person get? They all get 0. So my slope is 0. The slope of a horizontal line is 0. Now let's look at a vertical line. Here are my 2 points, 6, 4, and 6, 7. So I go over 6, up 4. Then I'm going to go over 6, up 7. This line goes straight up and down. Okay, so maybe my point's a little bit bigger. How far did I rise? Well, I started at 4, and I went up 1, 2, 3 to 7. How far over did I go? Well, I started at 6, and I went to 6. I didn't move over at all. So my slope, rise over run, is 3 over 0. Can I divide by 0 ever? No. We cannot divide by 0. So the slope is undefined. I cannot define the slope because I can't divide by 0. I cannot cut things into 0 groups or 0 pieces. It doesn't work that way. Okay? So here we go. The very bottom. The slope of a horizontal line is always 0. M equals 0. The slope of a vertical line is always undefined. Make sure this is going in your notes, guys. The slope of a vertical line is always undefined. Okay, last 3 down here. Go ahead and pause it. Take a few minutes, maybe 5 minutes, and try all 3 of these. We're going to walk around, make sure everybody's giving it a shot. Do your best. Ask for help if you need it. It's important that you guys are able to do this. So let's go ahead and pause the video and give it about 4 or 5 minutes, and then come back and I'll show you how to do them. Go ahead. Okay, hopefully we all tried them. We have some answers. Let's check and see how they went. Find the slope of the line through the given points. Tell whether the slope is positive, negative, 0, or undefined. So let's plot our points. 3, -1 is right here. 3, 5 is right here. That line is straight up and down. The slope is undefined. Okay, can't do it. Let's look at this one. -2, 5, and 3, 4. That one's not vertical or horizontal, right? So that one's going to have a slope. I went down 1. So my rise is a -1 because I went down. That's a negative slope. I don't even have to know what the slope is. All I had to say was whether it's positive, negative, 0, or undefined. If the line's going down, it's going to be negative. So I went down 1, then we went over, let's see, it was a -2, so 1, 2, 3, 4, 5. Oops, 5. -1 over 5. And let's take the last one. 1, -1 is right here. 7, -1 is going to be off the screen, but right over there. That's a horizontal line. So the slope is 0. Slope is 0, horizontal line. Okay, go ahead and get started on the homework, guys. You may use the notes on the homework if you'd like, but before you leave, make sure they get put back on the filing cabinet where they came from. Don't take them with you, and we'll pass them out tomorrow. Okay? We'll put the homework up on the board for you. They're in the subnotes. It's day 7, I think, on your homework sheet, but we'll double check and we'll get it put on the board for you. That's due tomorrow. You're going to turn it in, so make sure you put your name on it. Do it on a separate sheet of paper because you're going to turn this in tomorrow. Get going. Everybody's working till the bell, please.